All right, team, this is the video for Safety 2, Requirement 3. This is post-occupation safety with M795 using the GFT setting method, okay? So let's jump right in. So Requirement 3, your battery moves to another firing point and you determine the following GFT setting to create a post-occupation safety. Determine post-occ safety for the following range safety card and the ammunition data from the executive officer. Your M777 Alpha 2 battery has lot alpha of 2 square HE and lot bravo of 6 square HE. So we've got two different square weights of ammunition on hand. And then here we have our GFT setting. So GFT Echo Charge 2, lot alpha Lima. Lot alpha refers to the 2 square HE, okay? So this GFT setting was shot or calculated with 2 square HE. Lot Lima refers to the propellant, range 8500, elevation 385, fuse 27.8, total deflection correction of left 1-3. All right, so since we're already here at the GFT setting, let's just go ahead and update the GFT setting. It doesn't matter which order you do this in. I can make notes on my GFT setting first, or I can start drawing my range safety card, but I'm gonna do my GFT setting first, okay? So let's look at this. Well, let's go ahead and draw our lazy Z because we know that we're going to need that in order to, find some of the information that we need, right? It's always a good habit to draw your lazy Z and extract all this data in the event that you need to calculate for range K, okay? And then I see over here that my total deflection correction is left 1-3. So I'm just going to go ahead and record the equation, right? If you need to see it, it's right here. Right, this is basically what I'm doing, and then I'm recording this equation down here. Total deflection correction minus drift at adjusted elevation is going to give me my GFT deflection correction. So total deflection correction minus drift at adjusted elevation is going to give me my GFT deflection correction. Okay. All right, let's go ahead and take our GFT, ensuring that we have the appropriate charge, right? One of the most common mistakes that people make is they don't pay attention to the charge. So this is charge 2, right? I'm gonna set off my manufacturer hairline at the should hit range of 8500. Okay, so I have that there. Now that that's at 8500, I'm gonna go ahead and place a blue dot at the elevation and a red dot at the time fuse setting. Okay, so let's get our map markers. So blue dot at elevation 385. Okay, so where is that? That's gonna be way over here. Move it here so I can look at it straight up and down. You got my blue dot at 385. Then I need my red dot at 27.8. 7.5, 6, 7 to 7.8. Okay, after I've created my blue dot and my red dot, I'm going to slide my cursor over until the blue dot touches range K. Once the blue dot's touching the range K line, I'm going to get a straight edge. I'm going to trace the range K line like so. Just like that, okay? And record elevation up there at the top. Now take my red dot and throw it over to the fuse K line. Once the red dot is touching the fuse K line, I'm going to go ahead and trace it with a straight edge. And label that with TI for time. All right, set it back off at my should hit range of 8500. I actually set off at elevation 385. I need a couple of pieces of information at elevation 385. Okay, first thing is I need my drift to adjust elevation, so let's read up. So that would be left 9. So that's left 1-3, left 9. So imagine the lefts is positives and the rights is negatives. So that's positive 1-3 minus positive 9. So that would be what? That would be positive 4, right? We'll put in a calculator. If we're ever unsure, just put in our calculators in case. Yep, so that's positive 4, so that's gonna be left 4 is my GFT deflection correction. Let's go and record that up here. So I'm gonna take my black map marker, and on the top right is where I record GFT deflection correction, which is left 4. So again, this is gonna be my GFT, and then my total deflection correction I record on the top left as left 1, 3, and then I circle it. Why do I circle it? So I know that's the one I'm not supposed to use. Okay. So now that I have that, let's go ahead and get the rest of the data for our lazy Z. So what is my range at adjusted elevation? It looks to be, let's see here, that's 8,000, 81, that's 8210. Should hit time fuse is 27.4. All right, let's go ahead and find our total corrections. So did hit data minus should hit data. So my total range correction is negative 290. Okay, and then my time correction, so 27.8 did hit time minus should hit time of 27.4 gives me positive 0.4. Okay. All right, so I don't really need this. The reason why I do this is because I like to make sure that I'm still able to perform this step in the event I need to do range K. Because if I need to do range K, now all I have to do is just divide my did hit range by my should hit range. So if I needed to find range K very quickly, I could just do range K equals 8210 divided by 8500. 8210 divided by 8500. So that's going to give me 0.9659. So in the event that I had to use range K, I could just rapidly solve for it, right? We're not going to need it for this problem because we're using the GFT setting, but that's why we have to draw out our lazy Z, okay? And we always have to find our GFT deflection correction, always. All right, so let's go ahead and look at our range safety cards. So firing point 191, 777, low angle, Mike 795, 231, 739 alpha 1, 767, 732. All right, my left limit is 5.9, my right limit is 0.5. Let's go ahead and find our azimuth of light. So this one's going to be weird, right? Because I have my left limit is on the, let me get my protractor right here. My left limit is on kind of the left side of the 6400 line of the north line, and then my 0500 is on the right side, right? So I have to do something kind of special here. So what I'm going to do is I am going to take 0500, subtract 6400, that's going to give me a negative number, add 5900, divide that by 2, so that comes out to 0. So let me try that again. So 0500 minus 6400 equals, that's 5900 plus 5900 divided by 2. So my azimuth of lay is actually going to be 0, 0, 0, 0, or you could call it 6400, right? So what I always do as a sanity check is I look at my protractor and I say, okay, if 0500 is here and 5900 is, let's see here, is here, where generally speaking is it halfway? So I go in 100, 200, 300, 400, 500, 600. Yeah, so they meet exactly halfway. So that checks out. So azimuth of lay 0, 0, 0, 0 checks out. In the event that I ever have a left limit and a right limit that cross the 6400 line, I just subtract 6400 from the right limit and then take that value, add that to my left limit, and then divide that by 2. And that's going to give me my new value. All right. Unless the right limit is further away from the 6400 line than the left limit is, in which case we would just do the opposite. But for this one right here, it would be 0, 0, 0, 0. And like I said, I always get a protractor out just to sanity check myself on that. Okay. All right, so our low angle min range. So low angle min range is 7,000. Fuse time min range is 7,200. Maximum range is 10,000, and I'm shooting charge 2. Good, because that matches my GFT setting. All right, dog leg from azimuth 0,200 to 0,500. Minimum range is 7,700. Okay, so I have a min range dog leg, and now my battery altitude is 340. All right, so let's look at our altitudes. So at range 7,000, that is a minimum range. I need a max altitude. 7,200, that is a minimum range. I need a max altitude. 7,700, that is a minimum range. Also need a max altitude. And then at 10,000, that is a maximum range, so I need a minimum altitude. All right, so the range safety card is complete. Let's go ahead and make our basic safety diagram. Okay, we'll start off with the admin data up here at the top. So location is fracking point 191. All right, the altitude we said was 340. Charge 2, fuse, PD, time, VT. Okay. Azimuth of lay we said was 0, 0, 0, 0, or 6400, whatever you want to call it. I like calling mine 0. Okay. All right, so let's go ahead and draw our diagram. All right, so we're going to have a min range dogleg on, from azimuth 0, 200. So min range dogleg on the right side. So that's going to be like, it's going to look something like that. Okay, something like this. Okay. All right, so let's do our azimuths first. So on the left side, my azimuth is 5,900. On the right side, my right limit is azimuth 0,500. Okay, and then my dog leg from azimuth 0,2 to 0,5, so this is azimuth 0,200. Okay, and then we can convert those to deflections real quick. Okay, so to get from 0 to 5,900, what do I have to do? So the math I'm going to do instead of, because if I was to do 0 minus 5,900, it's going to give me a negative number, which doesn't make any sense. So I'm going to do 6,400 minus 5,900. I have to go left 500 mils. All right, now to get from 0 over to 0,500, I have to go right 500 mils. Okay, and then from 0 to, let me see how I want to do this. Do it right there. 0 to 200, I have to go right 200 mils. All right, let's do our range lines. So my first min range line is going to be 7,000. Yep, 7,000. And that altitude at 7,000 is going to be 420. All right, where's my, so fuse time is 7,200. Make sure it doesn't surpass my dog leg, 7,200. Yep, okay, so I'm good to go. All right, so I got my min time range line right here. That is at range, it's a little crooked, that's okay. It's at range 7,200. Don't need an altitude for that. And then my dog leg min range is 7,700. And that altitude is at 7,700. We said it was 440. Okay. Then my max range, overall max range, it's going to be 10,000. It's already raising some red flags for sight, right? Max range 10,000, and that altitude is 300. Okay, and I can just go ahead and apply my deflections real quick. So let's see here. So 3,200, left 500, so that's add 500. So that would make my left deflection 3,700. Because I'm doing post-Occ, what am I going to do? I'm immediately going to add my GFT. My GFT deflection correction, which we said was left 4. The reason I do that is so I don't forget at the end, so I don't forget at my last step. Okay, I need to go right 200, so 3,200 minus 200 would be 3,000. Record my GFT of left 4, and my drift of whatever, and that's going to give me my final deflection there. Okay, azimuth 0,500, I got to go right 500, so that's 3,200 minus 500 is going to give me deflection 2,700. Okay, I need to add my GFT. I never give myself enough room on these things. Let me move it up. Just move it up. 0,500, 2,700. All right, I'm gonna add my GFT of left 4 and then my drift, which we're gonna find later, and that's gonna give me my deflection on the right. Okay, so my basic safety diagram is complete. So now I can move on to my computation. So let's fill this out. So this is charge 2 Lima. I'm gonna set this aside because I don't need this. Where are we? Charge 2 Lima, shell mic 795, fuse PD time, and VT. Projectile family is mic 795. That's the Alpha Romeo 2 TFT, okay? Now, I'm gonna be solving for 2 different square weights, right? I'm gonna be solving for, what did we say, actually in our known data, stand by. We said it was 2 square lot alpha, right? 2 square lot alpha, that is for my GFT setting. And then I have 6 square lot bravo. Okay, so my 2 square lot alpha. So technically that is a decrease from the standard square weight of 4 square, but my GFT setting that I'm using here was shot with 2 square lot alpha, right? So this already encompasses whatever range corrections I would need to do for 2 square. So if I shot a GFT setting with 2 square becomes the new standard. So I don't have to do any sort of range correction for 2 square. I can just use the diagram range. Now that changes when I get down here to lot bravo, but we'll discuss that once we get there here in a moment, okay? All right, so let's start recording our diagram ranges. So first one, diagram range is 7,000, followed by 7.2, then 7.7, and then 10,000, 10,000, red flags going off for sight, which we'll discuss in a moment. We do not have a range correction, which is going to give us the same total range multiplied times range K. It's going to give us our entry range of 7,000, 7,200, 7,700, and 10,000 at charge 2. All right, so now let's go ahead and find our VI. So do I need elevation quadrant for my min range of 7,000? Yes, I do, so I need my VI. VI is target minus battery, so that's 420 minus 340. So I get a VI of positive 80 for range 7,000. All right, what about 7,200? Do I need a VI or sight for that? No, I don't, nor do I need elevation or quadrant, so I'm just gonna go ahead and line through those right now. All right, but what about for 7,700? It is a min range line, right? It's a min range line, so I do need my VI for that. Okay, so that's 440 minus 340 gives me a VI of positive 100. Okay, and then for 10,000, it's my max range, so I do need my sight and quadrant, so that would be altitude 300 minus battery altitude of 340. Give me a sight of negative 40. Or correction, a VI of negative 40. Okay, so for sight, just because we're using a GFT setting doesn't change anything. We can still use our GST to calculate sight. Okay, so let's do diagram range 7,000. So my VI is 80. And I am target above gun, charge 2, 7,000. All right, so I set that off. The 3 numbers I extract down here, let's make sure I can get on camera, looks to be like 124, 125, something like that. Let me see here. Once I start getting to 5s, I like to get, okay, yep. Yeah, I'm gonna call that one, yeah, that's 125. Okay. 125. So now I place the decimal to make the value as large as possible without surpassing the value of the VI. So that'd be 12.5. Then I express to the appropriate accuracy and then add the appropriate sign. So 12.5 expresses to 12. Already expresses to 12. And then because I'm low angle, sight carries the same sign as VI, which is positive. Okay. All right. So next diagram range 7,700. I have a VI of 100. Okay, mine does not go that far for some reason. So hopefully it goes this far. Yep, okay. All right, so VI of 100, diagram range 7,700 at target above gun for charge 2. Okay, so the three numbers that I extract are 1, 4, 7. Make the value as large as possible without surpassing the value of the VI. Give it the same sign as the VI for low angle, so that'd be positive 1.5 as my site. All right, now diagram range 10,000. I'm over 10,000, so there's gonna be some rules for placing the decimal that we'll discuss here in a second. So VI is -40. Every time I see ranges above 10,000 for site, that's gotta be a red flag. Okay, so -40, target below gun, range 10,000. Okay, so the numbers I extract are 5, 5, 5. Okay. Now, for ranges over 10,000, what do we have to do? We have to do rough math, right? So what is my rough math for ranges over 10,000? Let's just go ahead and record it on the back of our page here. So my three numbers I extract, so we had VI of -40, three numbers are 5, 5, 5. Okay, so rough math, remember the equation is VI divided by range in thousands. And we said our VI was -40 divided by what was our range in thousands, so that'd be 10. So 40 divided by 10 gives me 4. Okay, so technically that'd be 4.00. I always like to have 3 digits here for my rough math, okay? And the three numbers I extracted were 5, 5, 5. Now I want to place the decimal to make the value as small as possible, but still being larger than the rough math. So it's basically the opposite of regular low angle sight for ranges below 10,000. So that would be 5.55. Once I place the decimal, express the appropriate accuracy, so that'd be 6. Give it the same sign as the VI for low angle, so sight is -6 for range 10,000. Got to watch out for those sight problems over 10,000. Those things are tricky. You got to remember to do the rough math. Okay, as I cross the solid black line, I'm going to be using entry range to calculate all of my data to the right there. Just so I don't accidentally extract from diagram range, I'm going to cover it up, even though they're the same. It's just a good habit to have. Okay, so I need elevation at entry range 7,000. I'm literally just going to pick up my GFT, set off range 7,000 on the black manufactured hairline. Okay, once I set it off there, I can then extract my elevation from the blue elevation gauge line. Okay, and I extract elevation 291. 291. Quadrant is a summation of elevation and sight, so that's 291 plus 12 gives me a quadrant of 303. Safety T value, I'm going to go ahead and circle that. Okay, do I need a min time fuse setting at the min range line of 7,000? Nope, because the min time range line is up here at 7,200, so I don't need that. But I do need my min VT time fuse setting, which is a function of time of flight. Okay, so before I extract time of flight from here, we're going to refer back to Appendix Fox inside of our TC, page Fox-1. This is how I extract data with my GFT, either without or with a GFT setting applied. So I'm going to look for what I'm looking for, okay? So I'm going to turn to the next page, and I see that, here we go, time of flight, right? Let's see here. So time of flight is a function of elevation. We're going to place manufactured hairline over the range, read down. Oh, no, that's for without a GFT. We have a GFT setting applied. Place manufactured hairline over range, determine elevation under elevation gauge line, which we already did. It was 291. Then place the MHL over that elevation, read down to time of flight. Okay. until we get super comfortable extracting data from the GFT with the GFT setting, make sure you always refer to appendix Fox. So I'm going to set the black manufactured hairline over elevation 291. Once that's done, I'm going to read down the manufactured hairline and extract my time of flight. And I get 21.3. Okay, now I add 5.5. So that gives me 26.8. And then I express that up to the next whole second for VT. For VT, we always express up to the next whole second for safety. Okay, so that's 27.0 safety T value. Let's go ahead and circle that. Now I need my drift. How do I find my drift? I could go back to appendix Fox, but my drift basically says I place the MHL over the elevation of 291. I read up and extract the drift, which was left 7. All right, so I've drifted left 7. Okay, now so for entry range 7200, so this range line right here, what do I need? I don't need elevation or quadrant. I don't need time of flight, VT fuse setting, or drift. But I do need a mechanical time or electronic time fuse setting because we have 767s. Entry range 7200, so set off the MHL on 7200. All right, and then I read from the red time gauge line. So it looks to be about 22.4. Safety T value, go ahead and circle it. Okay. Now, let's look at this tricky one here. So now this min range line of 7700. So I'm going to need to find both elevation and quadrant, right? Because it's a min range line, just like this one. What else did I have to find at this min range line? I also have to find time of flight and my min VT fuse setting, okay? What else do I need here? Because my min time range line falls below the min range line dogleg, I also have to find my min time fuse setting as well. So the only thing I don't find at this particular range is my drift. That's the only thing. For a min range dogleg, where the min time range line falls below the min range dogleg, I have to calculate literally all of the data except drift. Okay, so let's go ahead and find elevation first. So we're gonna set it off on range 7700. So the MHL on 7700, 75, 76, 7700. Okay, so looking at the blue elevation gauge line to extract my elevation, I see 333. Quadrant is a summation of elevation and sight, so 333 plus 15 gives me 348 as my quadrant. Okay, next I need my time. So I read time from the red time gauge line. I see a time of 24.4. Circle that because of safety T value. All right, next I need my time of flight. So remember how I find my time of flight? I set off the MHL on my elevation of 333. Okay, and then I read down to see, let's see here, that is 333. I read down to see a time fuse setting of 24.1. At 333, right? 33, yep, 24.1, okay. Time of flight plus 5.5, so 24.1 plus 5.5 gives me 29.6, which expresses up to the next whole second of 30.0 as my min VT fuse setting for that range. Okay, and then for range 10,000, what all do we need in our max range? I don't need a max time fuse setting or VT fuse setting, but I do need drift and quadrant. Okay, so let's set off manufacturer hairline at range 10,000. Okay, all right, so elevation that I extract there. Okay, so this is gonna get kind of tricky because I gotta make sure I'm looking at my gauges here. So that would be 500. The next tick would be 505, followed by 510. So that's just short of this tiny short tick halfway between 500 and 510. So that would be 505 is my elevation. So 505. So let's do 505 minus 6 gives me a quadrant of 4, 9, or 8. I'm sorry, actually, I said it was just shy, so that should be 504. That should be 504 is my elevation. Yep, so 504 minus 6 would be 4908. Okay. Make sure we are reading our instruments correctly. That's always why when I do this, I always give mine a second glance after I record the value. Just give it a second glance just to make sure what you're recording is accurate. Then we need our drift. And remember how we find our drift? We set off drift. We set the manufacturer hairline at elevation 504, read up for drift. So elevation 504, read up for drift. It's a good thing that we're doing that, because if we didn't do that, we would get the wrong value in this particular case. My drift is left 1-3. Okay, so now that I have that, let's just go ahead and apply our drift up here since we're here, okay? So right here at deflection 3700, which side is open? Left side is open. Left side is open for business, so that is least left. So that's 3700 plus 4 plus 7 gives me 3711 as my left deflection. Circle it because it's safety value. All right, so what about at deflection 3000? Which side is open for business? Right side is open, so that's least left most right. So that is left 1-3. So that's 3000 plus 4 plus 1-3 gives me 3017 as my dog leg deflection. Then on the right, I have right side is open, so least left most right, so left 1-3. So that's 2700 plus 4 plus 1-3 gives me 2717 on the right. Okay. Okay, now that I have this, I can move on to 6 square lot Bravo. Now remember that whenever I'm doing this adjusted square weight to find my new entry range, this is based off of 2 square being the new standard, because this is the GFT setting. I'm going to use this GFT setting. So if this GFT setting was shot with 2 square, I'm trying to solve for 6 square, I have an increase of 4 square, right? So let's see if we need to find values for which particular ranges. The way that I do this, right, I look at my rules for calculating safety for an increase in square weight. If I have a min range with a positive value in column 1-9, I update. If I have a min range with a negative value, I don't. If I have a max range with a positive value, I don't. And if I have a max range with a negative value in column 1-9 of the TFT, I do have to update, okay? So let's extract our Alfa Romeo 2, turn to charge 2, ensuring that we are in the correct charge. Refer to table Fox. Okay, let's look at our first range, diagram range of 7,000. So diagram range of 7,000 is a minimum range, is a min range, and what value does it have in column 1-9 with a positive value? A minimum range with a positive value means I have to update it, okay? So that's going to be diagram range 7,000. I'm going to have to update. We'll just go ahead and record it all. So it's going to be 2 Lima. Non-standard condition. So the non-standard condition is 6 square minus the standard condition, which is 2 square, is going to give me a increase of 4 square. And for range 7,000, the diagram range correction is positive 1, 9. We'll do our math here at the end, okay? So 6 square is going to apply to everybody, so 2 square, so will this. All right, next diagram range is 7,200. Let's turn the page. 7,200, I have a positive value in column 1-9 again, so I will have to recalc, so 7,200, and that value is positive 1,9. Next range is 7,700. It's a min range of 7,700. I also have a positive value in 7,700, so it's a min range line with a positive value. I do need to update, and that is positive 1,8. And then finally, let's see here, range 10,000. Range 10,000 is a maximum range with a positive value. A max range with a positive value, I do not need to update. Okay, so not worried about that. So let's put the TFT away and just do some math. All right, so I have an increase of 4 square, so 4 multiplied times a 1.9 meter range correction gives me positive 7.6, which expresses to positive 8.0 for diagram range 7,000. Next is, well, it's the same value, 4 times 1.9, so that's positive 7.6, which will express to positive 8.0. And then I have, let's see here, 1.8 multiplied times 4, which gives me positive 7.2, which then expresses to positive 7.0. Okay, so now that I have my range corrections, let's go ahead and pop them in down here. So diagram range, 7,000, 7,200, 7,700. All right, so 7,000, do I have a range correction? Yes, I do. Positive 80, which gives me total range of 7,080 multiplied times range K of 1.0000, which will apply to all ranges. Gives me an entry range of 7,080 at charge 2. VI and site stay the same as up here. Okay, diagram range 7,200 plus a range correction of 80 gives me a total range of 7,280 multiplied times range K gives me an entry range of 7,280 at charge 2. At 7,200, I didn't need any of that, so I'll just do that there. All right, so 7,700, I do have a range correction of positive 70. Total range of 7,770 multiplied times range K gives me entry range of 7,770 at charge 2. VI, we said, was positive 100 with a site of positive 15. Okay, so now as I cross the solid black line, I use my entry range for everything. So let's take our sticky note, cover up everything to the left of entry range, and then pick up our GFT, set off entry range 7,080 to find elevation. Okay, so 7,080, let me see, I need to extract elevation, I get 296. And 296 plus my side of 1.2 comes out to 308 for my quadrant safety T value. Do I need a min time view setting? If I can just look up here and I just need to recalc all the same stuff I did up here. So I don't need that. I do need a time of flight though. To find time of flight, I set off the MHL at elevation 296. Okay, and then I read down the manufacturer hairline, I get time of flight of 21.7. Okay, so then 21.7 plus 5.5 gives me 27.2, which then expresses up to the next whole second for VT, so that's 28.0. Don't forget that 0.0. All right, I do not need to recalculate drift. Next is entry range 7,280. What do I need at 7,280? Let's look at what we have up here. All I need is my electronic time. I don't need anything else. Okay, so pick it up, set it off at 7,280. Okay, so at 7,280, I see a time fuse setting of 22.7. Yep, 22.7. Easy. And then at 7,770, what do I need? I need everything. I need everything at that range. Okay, so let's start with elevation. Entry range 7,770. Just making sure I'm reading this very precisely, okay? And then I see I have elevation of 3,357. All right, so then 337 plus a site of 15 gives me 352. Is my quadrant. All right, now I need a time fuse setting. Time fuse setting was, let's see here, 24.7. Next, I need time of flight. So time of flight, I set off the black manufacturer hairline at elevation 337. All right, then I read down the black manufacturer hairline to get my time of flight of 24.3. All right, then I add my 5.5 second safety buffer. So that gives me 29.8, which expresses up to 30.0. Okay, now that I have all my values, let's go ahead and build our safety T. All right, we're gonna need to record our GFT setting down here. So our GFT setting, we said it was GFT setting echo, charge 2, lot alpha Lima, did hit, or correction, should hit range of 8500, elevation of 385, time of 27.8 with a fuse mic 767, total deflection correction of left 1.3, and a GFT deflection correction of left 4. Location we said was firing point 191. The altitude for the battery we said was 340. We're shooting charge 2, shell mic 795, fuse PD time and VT. Azimuth of lay was 0000, or you could say 6400. It's the same thing. Okay, so for max quadrant, so let's look at, or well, let's start with our deflections actually. So deflections from left to right, so 3711, I've got 3 of them, right? So I'm gonna separate deflections into 3 separate deflections. So 3711, followed by 3017, and 2717. Sanity check, deflections should be getting smaller as I move left to right, they are, so that checks out, okay? Now max quadrant, there's only one max quadrant, so let's knock this out. So max range of 10,000 has a quadrant of 4, 9, or 8. Okay, so that one's good to go. All right, so I have a min range dogleg. Anytime I have a min range dogleg that looks like this, my safety T is literally gonna be split right down the middle from below the deflection lines. Okay, I'm gonna have all of my values on the left side of the safety box, the left side of the diagram, on the left side of the safety T, and everything on the right side of the safety T, okay? So let's label these first. So first I need min quadrant for HE 2 square, lot alpha, min quadrant for HE 6 square, lot bravo, min time for HE 2 square lot alpha, min time for HE 6 square lot bravo, min VT time of, and then my overall min VT time, right? Just whatever's gonna be the most restrictive between them. Okay, so let's start with our min quadrant for HE 2 square lot alpha. Up here. Okay, so let's do the left side and the right side. So let's do a 2 square lot alpha, right? So between deflection 3711 and 3017, so right here, which is going to be this side, between 3711 and 3017, what is the min range line? Min range line is 7,000. So it's diagram range 7,000. What's my quadrant? It's 303. So 303 goes on the left. And then what is between deflection 3017 and 2717? That is this right here. This is this min range line of 7700. So 7700 would be 348 on the right. Okay. Now what about my min quadrant for HE 6 square lot bravo? We just do the exact same thing. So if I found 7,000 on the left for lot alpha, I just find 7,000 on the left for lot bravo. So that would be 308 on the left. And then on the right, I found it for 7700. So this would be 352 on the right. All right, now we go to our min time, okay? So min time on the left, so between deflection 3711 and 3017, between these two deflections here, my min time range line is 7200. So 7200 on the left is going to be 22.4 for lot alpha. And then on the right, so this is between deflection 3017 and 2717, it would be min range 7700, right? Min range 7700 is acting both as my min range line and my min time range line on the right side, because if I extended that min time range line out here like this, I could possibly have a round function prior to this min range line on the right. That's why we now make this min range line of 7700 basically a min range and a min time range line. Okay, so that's 7700. So we said that was 24.4 on the right. Now we do the same thing for 6 square lot Bravo. So 22.4, that was at 7200. So at 7200, I have 22.7 on the left side for lot Bravo, which leaves me with 24.7 on the right. Okay, and then my min VT time. I'm gonna pick the most restrictive min VT time. So on the left, I have min range 7000. So at 7000, I have 27.0 for lot alpha. At 7000, I have 28.0 for lot Bravo. So I'm gonna go with 28.0. I'm gonna go with the most restrictive, 28.0. Okay, and then min VT on the right. So that's gonna be at min range 7700. So 7700 here for lot alpha is 30.0. 7700 here for lot Bravo is 30.0. So it's both the same, so I'm just gonna leave it as 30.0. All right, there you have it. So that's what the safety T looks like for a min-range dog leg, right? A min-range dog leg is gonna be split down the middle below the deflections. We're gonna have the values on the left and the right. So that completes safety T requirement 3, which is post-occupation safety for 795 with a GFT setting.